In this video, we will solve question number 42 from GATE 2020 chemistry paper. Now the question is the following. The change in Gibbs free energy of formation and change in enthalpy of formation for Fe gas are given at temperature 298 Kelvin. Now assuming the change in enthalpy of formation is constant in the interval 250 Kelvin to 375 Kelvin, we have to find the change in Gibbs free energy of formation rounded up to the nearest integer for Fe gas at 375 Kelvin temperature. Now these are the four options that are given. Now first let's understand the basic concept of Gibbs free energy. Now here free or available energy means energy which is useful to do work. That means the maximum amount of work other than expansion work a system can do in a reversible process at constant temperature and pressure. Now we can write down the expression of Gibbs free energy as G equal to H minus Ts, where H is the enthalpy, T is the absolute temperature, S is the entropy. Now we can also write H equal to U plus PV, where U is the internal energy, P is the pressure and V is the volume. So finally we can write down the expression of Gibbs free energy as follows: G equal to U plus PV minus Tc, where Gibbs free energy is the contribution of the enthalpy subtracting the thermal fluctuation contribution. Now if the system transforms from one state to another at constant temperature and pressure, then the change in Gibbs free energy, that means delta G, will be delta G equal to delta H minus T delta S, where delta H is the enthalpy change for the process and delta S is the entropy change for the process at the temperature T. Now under standard conditions we can write down this expression as follows: delta G0 equal to delta H0 minus T delta S0. Now at 298 Kelvin the delta G0F and delta H0F is given. Now from the using this equation, delta G0F equal to delta H0F minus T delta S0F, we can get the expression of delta S0F, that means the change in entropy for the formation. Delta S0F will be equal to delta H0F minus delta G0F divided by T. So delta S0F will be, by putting these values, 416.3 minus 370.7 divided by 298, which will be equal to 0.1530 kilojoule mole inverse Kelvin inverse. Now look at the unit of delta S0F very carefully. In the unit it is expressed at Kelvin inverse. That means per unit temperature, per unit Kelvin temperature, the amount of change in entropy is given. So it is independent upon temperature. Now it is given in the question that the change in enthalpy is constant in the interval 250 Kelvin to 375 Kelvin. So at 375 Kelvin also we can use this expression delta G0F equal to delta H0F minus T delta S0F. As the delta H0F is constant in this temperature, so we can use the value of delta H0F like at the temperature 250 Kelvin. So delta G0F at 375 Kelvin will be 416.3 kilojoule per mole minus temperature 375 Kelvin times the entropy value. So 0.1530 kilojoule mole inverse Kelvin inverse. So the delta G0F, that means the change in Gibbs free energy at temperature 375 Kelvin, will be 358.925 kilojoule per mole. Now in the question it is asked that you should be rounded up this value to the nearest integer. So as the decimal points it is in the 9 to 5, that means we can round round up this value to the nearest integer as 359 kilojoule per mole. So the correct option will be option A, which means the change in Gibbs free energy for the formation of Fe gas at 375 Kelvin will be 359 kilojoule per mole. Now for further details you can visit the following NPTEL reference. This is the NPTEL lecture series on the topic of Introduction to Chemical Thermodynamics and Kinetics, and the instructor is Professor Arijit Kumar Dev from Isaac Mohali. Thank you.